flying from New York to Los Angeles in just 3 hours. This used to happen only in science fiction movies. But now, the United States has taken action to turn this dream into reality. With a new executive order signed by the Trump administration, the path has been cleared for supersonic passenger jets to return to the skies. The goal is clear. By 2027, faster-than-sound commercial flights could be back. Can the new generation of aircraft pick up where Concorde left off 20 years ago, only faster, quieter, and greener? We'll cover all the details in this video. This isn't just about speed. This could be a revolution that transforms the entire aviation industry. Until 2025, there was a ban on overland supersonic flights within US airspace. This ban was enacted in 1973 due to environmental concerns. Noise pollution, public backlash, and technological limitations meant that supersonic jets like the Concorde never reached their full potential in the United States. And over the years, supersonic flight faded into something of a nostalgic memory. But everything changed on June 6, 2025. Donald Trump signed a presidential executive order titled "Leading the World in Supersonic Flight," initiating the process of lifting a 52-year-old ban. This order didn't just excite aviation enthusiasts, it also mobilized major players like Boeing, Lockheed Martin, and Boom Supersonic. So what does this executive order include? The FAA was instructed to develop a clear roadmap within 180 days for lifting the ban on supersonic flight over US airspace. Noise standards must be redefined to certify next-generation supersonic aircraft in a way that minimizes their environmental impact. R&D incentives and public-private partnerships were prioritized to ensure the US leads in this field. Trump's move was not only technological, but also a political statement. America won't just fly, it will be the fastest-flying nation. In other words, this executive order reflected a superpower vision projected into the skies. Supersonic flight is no longer a distant dream of the past. This decision could pave the way for 3-hour supersonic flights between New York and Los Angeles by 2027. And this is only the beginning. Today, supersonic flight is back in the spotlight. But for 50 years, the United States didn't want this technology in its own airspace. Why? It all began in 1973 when the Federal Aviation Administration, the FAA, made a landmark decision. That ruling banned supersonic flights over land. The reason? Sonic booms. That massive thunder-like sound produced when a plane breaks the sound barrier. Supersonic aircraft of the time, like the Concorde, could reach speeds of up to 1,300 miles per hour. But at those speeds, the shockwaves generated were powerful enough to shatter windows on the ground. Public complaints, political pressure, and scientific reports all came together. Even though it was technically possible to fly that fast, the impact of supersonic flight over land became a major concern. And the problem wasn't just noise. Supersonic jets had extremely high fuel consumption, their carbon emissions were far from eco-friendly, and ticket prices on aircraft like the Concorde only catered to the ultra-wealthy. All of this led the FAA to say no to supersonic flights in 1973. That's why the Concorde was only allowed to fly transoceanic routes to the US, a direct result of this ban. The decision was so lasting that for half a century, no commercial supersonic aircraft has broken the sound barrier over US land. But now, a new era is beginning. Next-generation supersonic aircraft are being designed to be quieter, more efficient, and more environmentally compatible. In short, lessons have been learned from the past. Now the real question is, technology has advanced, but can the public be convinced this time? The supersonic aircraft making headlines today aren't replicas of the Concorde. On the contrary, they represent a completely new generation equipped with quieter, lighter, smarter, and more eco-conscious systems. So what exactly do these next-gen supersonic jets promise? 1. From sonic boom to whisper boom. New designs aim to soften the shockwave effect that occurs when a plane breaks the sound barrier. NASA and several private companies are developing low-boom technology. The goal is for the sonic signature to sound more like distant thunder than an explosion in the sky. 2. More efficient engines. Unlike the Concorde's Rolls-Royce Olympus engines, the new supersonic jets are expected to reach high speeds without using afterburners. This means lower fuel consumption and a much smaller carbon footprint. 3. Sustainable fuels. These aircraft are being developed to operate not only on traditional jet fuel, but also on SAF, sustainable aviation fuel. This minimizes environmental impact and aligns with global climate goals. 4. Digitally optimized aerodynamics. Instead of relying solely on traditional wind tunnel testing, engineers are now using AI and CFD, computational fluid dynamics, simulations. The result? Jets that are lighter, quieter, and more aerodynamically efficient. 5. New players entering the game. Boom Supersonic, NASA, Lockheed Martin, and even defense industry giants are actively pursuing supersonic projects. Boom's Overture jet, for example, is being designed to carry between 65 and 80 passengers at speeds up to Mach 1.7. And, most importantly, 6. This time, humanity might be ready. With environmentally responsible designs and quiet supersonic systems, these jets are now in a stronger position, not just technically, but politically and socially. So this time, it won't be technology that makes the difference, it'll be public acceptance. And it seems the world might finally be ready. The company closest to building the supersonic passenger jet of the future, Boom Supersonic. This Colorado-based startup takes its name from the sonic boom and has one clear goal: to create a supersonic aircraft that's faster, quieter, and more sustainable than the Concorde. So what exactly is Boom working on? Boom's Overture supersonic jet aims to rewrite the rules of commercial aviation. Here are Overture's technical specs in brief. Mach 1.7 speed, that's nearly twice the speed of sound. 4,250 nautical mile range, that's about 4,880 statute miles, or roughly 7,800 kilometers. 65 to 80 passenger capacity, ideal for a smaller premium passenger profile. 100% SAF, sustainable aviation fuel, compatible, targeting carbon-neutral operations. Noise reduction systems, especially designed to prevent sonic booms over land. So far, Boom Supersonic has received pre-orders from major airlines such as American Airlines, United Airlines, and Japan Airlines. Additionally, the US Air Force is collaborating with Boom on a special version of Overture that could be used for presidential or military missions. Boom plans to conduct its first commercial test flights in 2027. The company's goal? To be fully operational by 2030 and launch the first wave of supersonic travel. Why is Overture such a big deal? Because Overture is not just an airplane, it's the clearest answer to the question, is supersonic commercial aviation still possible? Boom Supersonic is taking the legacy left by the Concorde and reshaping it with today's technology and a focus on sustainability. So yes, flying from New York to Los Angeles in just 3 hours is no longer a dream, and the most tangible form of that dream is Overture itself. Supersonic flights sound incredible, crossing continents in just 3 hours, cutting-edge design, and massive time savings. But what about the economics and comfort? Who is this experience really for, and how much will it cost? Let's talk ticket prices. Boom Supersonic CEO, Blake Scholl, says the goal is to offer supersonic travel at the price of a business class seat. That means ticket prices similar to long-haul business class on conventional airlines, roughly $4,000 to $5,000 for a New York-London flight. Back in the Concorde era, the adjusted cost today would be between $12,000 and $20,000. Boom aims to make supersonic flight more accessible and break the mold of supersonic elitism. These new jets promise a blend of luxury and technology. Limited seating, 65 to 80 passengers for a more exclusive cabin atmosphere. Quiet interiors, outfitted with advanced noise reduction systems. Large windows and spacious seating, designed for a modern jet experience. Digital connectivity, in-flight Wi-Fi, real-time messaging, and live streaming. Optimized cabin pressure and humidity helps reduce jet lag. These flights won't just be chosen for speed, they'll also appeal to those seeking comfort and prestige. At first, they'll primarily target top-level executives, professionals needing fast international connections, VIP travelers for whom time is more valuable than money. But over time, as production scales and efficiency improves, supersonic travel could expand to a much broader audience. Supersonic travel could revolutionize the way we move through time. But how friendly is that speed to our planet? To break the sound barrier, supersonic aircraft must consume significantly more energy. Boom Supersonic's planned Overture jet may use up to 50% more fuel per passenger compared to traditional commercial airliners. That means higher carbon emissions and a larger environmental footprint. And just as the aviation industry is pushing to meet carbon neutrality goals, this presents a serious contradiction. All next-generation supersonic jets are expected to run on 100% SAF, sustainable aviation fuel. SAF can reduce carbon emissions by up to 80% compared to traditional jet fuel. But here's the catch. Today, global SAF production accounts for less than 0.1% of total aviation fuel demand. Until SAF becomes cheap, widespread, and truly sustainable, supersonic travel will continue to face environmental scrutiny. And the environmental impact isn't just about fuel. Supersonic jets create sonic booms, intense noise bursts caused by breaking the sound barrier. These booms can cause serious noise pollution over cities and natural areas. This was one of the Concorde's biggest issues. Boom Supersonic and other manufacturers are designing aircraft with noise reduction features and optimizing flight paths to minimize impact. But a definitive solution hasn't been found yet. If supersonic travel becomes active again, it won't just mean faster journeys. It will also trigger a major transformation in how airspace is used. Today's air traffic infrastructure is largely designed for subsonic commercial aircraft. But jets traveling at Mach 1.4 to Mach 1.7 cover the same distance in half the time. As a result, traditional flight paths will need to be redesigned. Supersonic corridors will be opened at higher altitudes. High-speed airways between major destinations may be introduced. One of the biggest obstacles to the return of supersonic flight is the sonic boom. That's why overland supersonic travel is still largely restricted. But the FAA and NASA are actively working on new regulations. Next-gen supersonic aircraft are being tested with low-boom technologies that produce softer shockwaves. Still, overflights of urban areas will remain highly controversial. Faster flights almost always mean higher fuel consumption, even with SAF in use. Widespread supersonic operations could lead to more high-altitude emissions. That in turn raises new concerns about climate change. Environmental groups and European regulators have already voiced opposition to these impacts. All of this brings one key question into focus. The return of supersonic flight isn't just a technological revolution, it's a complex balancing act involving regulation, environmental impact, and infrastructure. The return of supersonic travel isn't just about speed, it signals a major transformation in how aviation will evolve in the decades to come. Boom Supersonic may be leading the headlines, but it's far from the only player in the game. NASA and Lockheed Martin are developing quiet supersonic prototypes. Hermes is introducing hybrid rocket-powered aircraft concepts aiming for Mach 5. Spike Aerospace is focused entirely on supersonic business jets. This means the skies of the 2030s could include not just large passenger planes, but small, ultra-fast jets designed for elite travel. A London-New York flight dropping below 3 hours could transform global business travel. Routes like Istanbul-Singapore or Tokyo-Los Angeles could be cut in half. Even a New York-Dubai route might take just 7 hours at supersonic speeds. Just imagine flying to Dubai and back in the same day. This shift wouldn't just benefit business travelers, it could redefine tourism, logistics, and international commerce. But there's one key point to remember. This revolution depends not only on cutting-edge technology, but also on international cooperation and regulation. Airspace permissions, noise standards, and environmental compliance will ultimately determine how widely supersonic flights can expand. Supersonic jets aren't just about speed, they're poised to redefine the economics of commercial aviation. Today, first-class and business travelers account for a large portion of airline revenue. Supersonic travel will make that segment even more valuable. A business person willing to cross the Atlantic in 3 hours instead of 6 might happily pay a premium for the time saved. This opens the door to an entirely new airline business model. Fewer passengers, shorter flights, higher profits. Supersonic routes could also revive interest in long-haul connections that currently lack direct flights. With shorter travel times, once unprofitable routes could become highly attractive again. This shift would impact how airlines approach fleet planning, route networks, and even marketing strategies. Compared to traditional aircraft, supersonic jets are lower in passenger capacity, higher in fuel consumption, and more demanding in terms of technical maintenance. This forces airlines to confront a critical question: profit or prestige? Some may adopt supersonic jets for the branding advantage, while others will view it as a high-risk investment. But if supersonic travel becomes widespread, what is now seen as a luxury could become the new standard of high-speed air travel. Still, the success of this economic model won't rely solely on wealthy passengers. It will depend on building a solid, scalable, and sustainable operational infrastructure. Flying from New York to Los Angeles in just 3 hours might still sound like science fiction, but as of 2027, that dream is closer than ever to becoming reality. So, is it realistic? On June 6, 2025, the Trump administration issued a new executive order instructing the FAA and NASA to establish regulatory frameworks to support the return of supersonic passenger flights. This move isn't just about technological progress, it's also about removing bureaucratic barriers. It's no longer a question of can we build these planes, but who will allow us to fly them? As next-generation companies like Boom Supersonic, Hermeus, and Exosonic accelerate test flights, major players like Lockheed Martin are collaborating with NASA to develop quieter and more efficient supersonic jets. Several prototypes are expected to take flight between 2025 and 2026. If everything goes according to plan, 2026 will bring initial certifications, 2027 could see commercial launches, and by 2030, supersonic travel might become a daily reality on select routes. But risks still remain. High costs, infrastructure readiness, public acceptance, environmental impact, and most importantly, are passengers truly ready for this speed? Bottom line, supersonic travel might become the boldest comeback of the 21st century aviation, but this time it's not just about speed, it's about a transformation driven by technology, sustainability, and global cooperation. So yes, flying from New York to Los Angeles in 3 hours is no longer just a fantasy. This time, America seems determined to make it happen. If you enjoyed this video, don't forget to hit the like button and subscribe to our channel, and turn on notifications to stay up to date with everything about supersonic travel and aviation. See you at 40,000 feet on our next flight.